Every single day, we open the door of a refrigerator, grab a cold drink or fresh food, and close it back up without giving a second thought to the fascinating engineering operating continuously behind its walls. The transparent refrigerator shown in the image provides a rare, complete visual window into this remarkable system, peeling back the outer insulation to reveal a closed-loop thermodynamic process that relies on the principles of physics, chemistry, and mechanical engineering. Contrary to what many people naturally assume, a refrigerator does not actually create cold out of nothing. Instead, it is a heat extraction machine. Its fundamental purpose is to capture heat energy from inside the insulated cabinet and dump that heat outside into the surrounding room, lowering the internal temperature and preserving perishable items like vegetables, fruit, and milk. To understand how this transparent unit functions, one must trace the continuous journey of a specialized chemical fluid known as a refrigerant as it circulates through a carefully arranged network of copper pipes, valves, coils, and mechanical components visible through the clear casing. The entire process begins at the absolute heart of the mechanical system, located at the very bottom of the unit, the compressor. The compressor is the dark, heavy, motor-driven pump resting on the base plate. Its primary task is to take in low-pressure, cool refrigerant in a gaseous state and squeeze it with immense force. When a gas is compressed into a much smaller volume, its physical temperature and pressure spike dramatically due to fundamental laws of thermodynamics. The compressor forces this hot, high-pressure refrigerant gas out of its chamber and pushes it upward into the glowing copper tubing that snakes along the back and sides of the appliance. At this exact stage, the refrigerant is at its hottest point in the cycle, carrying both the heat it absorbed from inside the fridge during the previous loop and the mechanical heat generated by the compressor itself. As the hot, high-pressure gas travels through these copper tubes, it enters the condenser coil system. In a standard refrigerator, these coils are hidden on the back exterior or tucked near the bottom vents, but in this transparent model, they form a striking copper winding along the structure. The job of the condenser is to transfer heat from the hot gas into the cooler ambient air of the kitchen. As the room air comes into contact with the outer surface of the copper pipes, heat naturally flows from the hotter fluid inside to the cooler atmosphere outside. As the refrigerant loses heat energy while remaining under high pressure, it undergoes a phase change, transforming from a high-pressure gas into a high-pressure liquid. This liquid refrigerant continues flowing down through the copper lines, passing through a small cylindrical component called a filter dryer, which removes any tiny impurities or stray moisture particles that could cause corrosion or freeze and block the microscopic passages ahead. Next, the high-pressure liquid refrigerant reaches the expansion valve or capillary tube, which acts as a critical gateway between the high-pressure side and the low-pressure side of the cooling circuit. As the liquid is forced through this extremely narrow orifice into a much wider section of tubing, it experiences a sudden, dramatic drop in pressure. This rapid depressurization causes the liquid refrigerant to instantly flash cool, dropping to extremely low sub-zero temperatures while expanding into a cold, misty mixture of liquid and gas. This effect is very similar to how a pressurized aerosol spray can feel icy cold to the touch when sprayed for several seconds. Now icy cold and at low pressure, the refrigerant enters the evaporator section, which is prominently displayed at the very top of the clear refrigerator cabinet. The evaporator consists of a specialized set of fin tubing designed to maximize surface area contact with the air inside the fridge. As warm air inside the cabinet naturally rises toward the top, it passes over these freezing evaporator coils. Because heat always moves toward colder areas, the heat energy present inside the air and in the stored food is absorbed directly through the copper walls into the cold refrigerant liquid inside. As the refrigerant absorbs this heat energy, it reaches its low boiling point and evaporates, transitioning back into a low-pressure gas. To ensure that cold air is distributed evenly throughout every single shelf, the system relies on mechanical airflow components visible near the evaporator. At the top of the cabinet, a motorized blower fan draws warm air up from the lower compartments and forces it directly across the freezing evaporator coils. Once the air is thoroughly chilled, it is pushed back down into the main chamber. In this visible setup, an additional transparent fan mounted on the interior wall acts as a secondary air agitator, circulating the chilled air continuously around the glass containers, milk bottles, and fresh produce. This continuous forced convection prevents hot spots from forming and ensures that every corner maintains a precise, uniform temperature. To keep the entire process running efficiently without wasting electricity or freezing the food solid, the refrigerator relies on a sophisticated electronic control system. A digital thermostat module, clearly visible with its glowing temperature display reading 4 degrees Celsius, acts as the brain of the appliance. A precise temperature sensor located inside the cabinet constantly monitors the internal climate. When the sensor detects that the internal temperature has risen above the set target, such as when the door is opened or warm food is placed inside, the control board sends an electrical signal to energize the compressor and fans, restarting the cooling cycle. Once the interior reaches the desired 4 degrees Celsius, the thermostat opens the circuit, turning off the compressor to conserve energy until cooling is needed again. Through this continuous loop of compression, condensation, expansion, and evaporation, the transparent refrigerator demonstrates the elegant balance of thermal physics. The compressor pressurizes the gas, the condenser releases internal heat into the room, the expansion valve drops the pressure and temperature, and the evaporator absorbs heat from the food compartment to start the cycle all over again. By rendering every mechanical pump, copper conduit, fan blade, and sensor fully visible, this design transforms a common, everyday household appliance into an educational masterpiece, illustrating how human engineering successfully manipulates physical laws to keep our food fresh, safe, and cold.